Alright, so we're going to continue on from the last video and kind of looking at, you can kind of see this, and this should be in your notes, these drawings. What we did is we looked at the Lewis structures for these compounds and we drew them, and kind of a new way to do it from physical science. But we're going to build on this today, and we're going to actually look at something called the formal charge, because there may be more than one way to draw a molecule, and you're going to have to decide which way is the best way to draw it. So you do that by looking at the formal charge of the different atoms in the molecule. So I'm going to go ahead and show you how to do it, and then go and show you the rules with the notes. So I think it's just easier to see what's going on. So we're going to look at the first molecule here. We're going to look at ammonia. And we're going to take each individual atom and we're going to figure out what the formal charge is. So we're going to kind of look at, first, we're going to focus on nitrogen. And we're going to look at the number of electrons around it. Now, if it's got these single electrons up here, that means, that's a bad circling job, but there's 2 electrons attached to it. And then when you've got a bond, like you do here, here, and here, there are 2 electrons in that bond, but only one of them is with nitrogen. So basically, if you count around nitrogen, you've got 1 electron here, 1 here, 1 here, and 2 there, for a total of 5 bonding electrons. So to figure out the formal charge for nitrogen, you would go to the periodic table and figure out how many valence electrons it has. So if you look at the group that it's in, it has, it's really bad drawing, it has 5 valence. So you subtract those numbers. You're going to say 5 valence minus the 5 bonding electrons. So the formal charge of nitrogen in this compound is 0. Now hydrogen, since all that's attached to each one of those is a bond, that's just 1 electron that's attached to it, and it has 1 valence. So you would say 1 minus 1. So the formal charge of each one of these hydrogens is 0. If you're not catching on, we're going to be doing lots of practice, so just kind of bear with me. So that is the ultimate goal, to get the formal charges as close to 0 as you can. And the fact that all of these are 0 means this is the best way to draw this structure. So that's just one example. We're going to move on and we're going to go back and we're doing all the ones that you already have drawn. So if you want to go back in your notes, I went ahead and redrew them on these slides for you guys to see. So for this one, you drew this structure, you got CH4. So let's just focus on carbon right now. It has 4 bonds around it. That means in that bond, remember, there's 2 electrons, but we can only attach 1 to carbon. So that means there's 4 bonding electrons. And if you look at the periodic table, it has 4 valence. So that means the formal charge of carbon is 0. And if you take a look at hydrogen, again, it's got a bond attached to each one of them. So it's exactly like the last one we did. There's 1 valence, there's 1 bonding electron, so the formal charge of those are all 0. So this is the way that you would draw this structure, since all of those have a formal charge of 0. Next one, let's focus on the central atom first. Let's look at phosphorus. So you've got 1 bonding electron here. This makes 2. This would make 3. This is 4. And that's 5. So there are 5 bonding electrons in the nitrogen, or in the phosphorus. If you look at its valence electrons, it also has 5 valence. So that means the formal charge of phosphorus is 0 in that compound. Chlorine, if you look at chlorine, let's do this in black. You've got 1, 2, 3, 4, 5, 6, and then this bond, that electron would make 7 bonding electrons. And if you look at the periodic table, chlorine also has 7 valence. So that means it also has a formal charge of 0. Now, you could do those other chlorines, but if you take a look at it, they're all exactly the same. They're all going to be 0. So this is the way we have this structure drawn correctly. Let's take a look at CH2Cl2. Let me find mine really quick. Okay, so if we look at carbon, again, I'm going to do this one in black. You've got 4 bonds around it, so that would be 1, 2, 3, 4 bonding electrons, and you subtract that from the number of valence. Well, carbon has 4 valence too, so that means the formal charge of carbon is 0. Now let's take a look at the chlorine. They're both exactly the same, so if you do one of them, you've got both of them. You've got 1, 2, 3, 4, 5, 6, and then this bond would make 7 bonding electrons. And again, we said in the last one, it also has 7 valence. So the formal charge of the chlorines are 0. And then if you take a look at the hydrogens, they each have 1 bonding electron. So you're going to have 1 valence minus 1 bonding electron. So we're looking at a formal charge of 0. So we haven't run across anywhere we're going to have to redraw it. There will be some. I just kind of started you with some easier ones. So let's take a look at the next one. You've got HCN. There should be your drawing of it. So let's focus on carbon first. Carbon, it has 1, 2, 3, 4 bonding electrons. So 4 bonding electrons. We're going to subtract that from the number of valence, which is 4. So the formal charge of carbon is 0. Let's take a look at nitrogen next. Nitrogen, we have, let's see, 1, 2, 3, 4, and then 5. Remember, when it's got single electrons, unshared electrons, those each count as 1. So it has 5 bonding electrons. And nitrogen, if you look it up, it also has 5 valence. So the formal charge of that one is also 0. Hydrogen, again, it's just got that one bond. So it's got 1 bonding electron, and it also has 1 valence. So we're doing pretty good so far. Each one has a formal charge of 0. So now let's move on to those polyatomic ions. These were a little bit different. Remember, when we drew the structure, we had to add the number of the charge up here mattered, and we added the electron. So this was our structure that you should have drawn. So we're going to see if this is the correct structure that should be drawn with the lowest formal charges that we can. So let's start with bromine. Bromine has 1, 2, 3, this would be 4, this would be 5. So it's got 5 bonding electrons. I'm going to draw this up here. If you take a look at bromine, it has 7 valence. So that means I'm looking at a formal charge of 2 plus. 7 minus 5 is 2 positive. So that is not 0. So I'm thinking right there we could probably get something to have a lower formal charge. But let's go ahead and do the oxygens. They're all 3 the same if you take a look at them. So you're going to have 1, 2, 3, 4, 5, 6, and 7. So if you've got 7 bonding electrons, and if you take a look at, I don't know what I've done. Let's just X that out. So if I've got 7 bonding electrons, I need to subtract off the number of valence. Well, oxygen only has 6 valence. So I'm looking at 6 minus 7. So the formal charge of all those oxygens are negative 1s. Negative 1. So I need to make sure that I have a formal charge. Now your formal charge should match this charge on the ion. So if I've got 3 oxygens, they are a total of negative 3 and a positive 2. So negative 3 plus a positive 2 is that charge, is negative 1. The problem is we don't have a structure that is close to 0 as possible. We could draw this structure a little bit different to get those formal charges down. So I'm going to draw the new structure in black. So what I can do is I'm going to keep this oxygen the same, and I'm going to create a double bond. I'm going to get rid of those electrons there and make a double bond with oxygen. So it's only going to have 2 unshared sets of electrons. And I can do that again. Now if I do that, looking at the formal charges, if I look at bromine, bromine still has that pair here. I didn't do anything with those. So let's take a look at the formal charges of bromine. It is 1, 2, 3, 4, 5, 6, and 7. So now its bonding electrons are 7 and its valence are 7. So now its formal charge is 0. It's closer to 0. Over here it was 2 plus. So let's take a look at the oxygens. The two oxygens with the double bonds are going to be exactly the same. So if I take a look at this, it's going to be 1, 2, 3, 4, 5, and there's 6. So if I've got 6 bonding electrons, I don't know why this pen is not working very good. And I've also got 6 valence. That's going to be a formal charge of 0 on those two oxygens. So the fact that I'm getting my formal charges to 0 is going to make it a better structure. Now this oxygen over here hasn't changed at all, so it's still -1. And there is my charge on my ion. It's BrO3 minus, meaning it's got to have a -1 charge. So I can't get all of them to 0. That would mean I have a compound, all charges are 0. So I do have that -1 charge, so this would be a better structure to draw. So I do not want this one. So on a test, if I ask you for the best structure for bromate, then this is what you would have to draw, the one on the right. Let's try another one. Alright, sulfate. I have this structure drawn. This is what we drew last time on the last video. So I'm going to look at the formal charges of all these. So let's start with the sulfur. Sulfur has 1, 2, I'm not sure why this is not drawing right, 3, and 4 around it. So it's got 4 bonding electrons. But if you take a look at sulfur, it has 6 valence. This is really going to make me mad if I can't get this pen to work. So I am looking at, this is really sloppy, I'm sorry. I'm looking at a +2 formal charge. So +2 formal charge for sulfur. So if I look at oxygen, all 4 of these bonds are exactly the same. I've got 1, 2, 3, 4, 5, 6, 7 around it. So I would say there are 7 bonding electrons. But oxygen only has 6 valence. So that's going to be a -1 formal charge. And that would be the same for each one of these because they're set up exactly the same. So the fact that sulfur has a +2 formal charge, we need to get that closer to 0. So we do need to add some double bonds in there. So we're going to kind of do the same thing that we did in the other structure. I'm going to draw this one in black. So instead of having just single bonds around it, if I add a double bond with 2 of them, let's say like right here and right here, that's supposed to be a double bond, then that's going to take the number of unshared pairs down to 2 on these oxygen atoms. So we would have 2 unshared pairs on these, because if I take away a pair, I add a bond, which is what I'm doing. Now these oxygens here are not changing. They're still going to have their 3 sets of unshared pairs of electrons. So I end up with a structure that looks like that. So let's check the formal charges. If I look at sulfur, if I count the bonds around it, there's 1, 2, 3, 4, 5. And something doesn't seem right. No, I'm not counting right. 6. I didn't count that one right there. So it's got 6 bonding electrons around it. Well, we said earlier it has 6 valence. So that would give it a formal charge of 0, which is what we're looking for. So now we got to take a look at the oxygens. The one on the right and the one on the left are going to be exactly the same. So if we look at this, it's got 1, 2, 3, 4, 5, 6. Well, oxygen also has 6 valence electrons, so that would be a formal charge of 0. This one would be a formal charge of 0. And then the other ones didn't change from before because they are the exact same type of bond. And over here, see, they were -1, so they're going to be -1 here, and it's going to be -1 here. So that's a total negative charge of -2, which if you take a look up here, that's what I needed it to be. So this would be the correct structure to draw for sulfate instead of that one. The one on the right has lower formal charges than the one on the left. Alright, so let's take a look at carbonate. Oh, I wanted to skip this one. Ignore this one. We're going to go through it. I messed up, so I kind of redrew this one. So here is my carbonate. This is what I had drawn before. Let's take a look at looking at the formal charges for carbon. That would be 1, 2, 3, 4. It's got 4 bonding electrons around it. Well, it also has 4 valence, so that means the formal charge. I'm really going to get angry with this pen. I got a brand new pen, and it's not working. The formal charge of carbon is 0. Now, oxygen, the two of them are the same, but one of them is in a double bond, so we need to figure out, maybe let's do the one on the left. So I've got 1, 2, 3, 4, 5, 6, 7 bonding electrons, but oxygen has 6 valence, so that would be -1 for the formal charge. So this one would also be -1 because they're set up the same. The one on the right is going to be different though, so I'm going to do this one in green. So it's got 1, 2, 3, 4, 5, 6 bonding electrons, and it's got 6 valence, so that would be a formal charge of 0. So to me, this one looks pretty good. I do have that -2 charge on those 2 oxygen atoms, so that's about as close as I can get for formal charges. So this one was okay. We don't need to redraw this one. Alright, chlorate. Chlorite. I think it's chlorite. This is what I had drawn from the notes before. So if I'm looking at this one, if I try to look at the formal charges, if I start with chlorine in the middle, I've got 1, 2, 3, 4, 5, 6 bonding electrons around it, but it's got 7 valence, so that is going to give it 7 minus 6, it's going to give it a +1 formal charge. My oxygens are exactly the same, so I've got, let's see, 1, 2, 3, 4, 5, 6, 7 bonding electrons around it. Well, 6 minus 7, because it's got 6 valence electrons, is a -1 charge here. That would be a -1 charge over here. Well, in that case, I could probably get this a little bit closer to 0. I could definitely get, if I throw a double bond in there, so I'm going to redraw this. And I'm going to include a double bond there, which means I'm going to be taking away one of those pairs of electrons on that oxygen. I am having all kinds of trouble with this pen today, and I don't know why. So I'm basically taking away that pair of electrons right there and forming a double bond between that chlorine and the oxygen. This one over here I'm not going to do anything different with. I'm just going to keep it the same. So this is what I'm looking at for this structure. Now I can redo the formal charges. If I look at chlorine, except chlorine, I forgot, it still has those unshared pairs. That didn't change. So now if I take a look at the formal charge, I've got 1, 2, 3, 4, 5, 6, and 7. And it has 7 valence electrons. So this is sitting at a formal charge of 0 now. Now the oxygen on the left, if I take a look at that one, I've got 1, 2, 3, 4, 5, and 6 bonding electrons. And oxygen has 6 valence. So that's also looking at a formal charge of 0. The oxygen on the right hasn't changed. It's still -1, which overall I've got a 0, and a -1 for a total -1 charge, so that matches the charge of the ion. So this is the structure that should be drawn for chloride. If asked, this one would be incorrect. So let's move on. We got one more, so we've got phosphate. So let's take a look at the formal charges. If I look at the phosphorus, all I've got around the phosphorus is 4 bonding electrons. But it has 5 valence, so 5 minus 4 means this is sitting at a +1 formal charge. Each of the oxygens are all the same. So I've got 1, 2, 3, 4, 5, 6, 7 bonding electrons. That's going to make each one of those -1. So I'm thinking I could probably get the formal charge down a little bit. I could at least get the phosphorus down to 0 by adding a double bond. So if I take a look at taking this oxygen bond and making it a double bond and getting rid of a set of those electrons and just having that, then I could keep the other ones exactly the same with a single bond and keeping those pairs the same. So those stay the same. I can re-look at the formal charges. Phosphorus, if you count, it has 1, 2, 3, 4, 5 bonds around it now, and it has 5 valence, so that means it's sitting at a formal charge of 0 now. Now, all the other oxygens, these 3 oxygens have not changed. They're still -1. Nothing has changed about how they're drawn. But the one with the double bond, it's got 1, 2, 3, 4, 5, and 6 now, which it has 6 valence, so it's got a formal charge of 0. So that one's drawn a little bit better with some formal charges closer to 0. And it does add up to that 3 minus charge. So that would be, this is the incorrect drawing. This one would be the correct way to draw phosphate. Alright, so to review, that's kind of what we did, but now the actual rules come in. So there's going to be more than one way to draw a Lewis structure. To decide, you're going to do that bookkeeping that we've been doing where we're kind of adding up the bonding electrons. So it's bonding electrons and valence electrons, and you subtract them, and that's what that last thing, or the next slide, is going to kind of say. So you're going to take the number of valence minus the number of bonding electrons. So the formal charge of any atom in a molecule is the charge of the atom would have if all the atoms had the same electronegativity, meaning if they're sharing all those electrons equally in between those atoms. So here is what you did as you went through there. You took all unshared electrons, the ones that were the dots, the ones that were not shared, and you assigned them to the atom that they were found on. Any bond that you had, single, double, or triple, only half of those electrons were assigned. So we broke it up. If we had a bond, we put one to one atom, one to the other. And then to get the formal charge, what you did was you took the number of electrons assigned, meaning the bonding electrons, and you subtracted it from the number of valence. So valence, again, minus bonding electrons. So the formal charge of an ion must equal the overall charge, so we did that. So if we had phosphate, all of the formal charges would add up to that 3 minus. Now, if you've got a compound, like when you had NH3, compounds are neutral, so all of the formal charges should have added to 0. So, and that's what this second part is talking about. So the dominant Lewis structure is generally the one in which the atoms have formal charges closest to 0. And that's what we looked at. So we made sure, and I X'd out the ones that were not dominant. You found out which ones were dominant. So then a Lewis structure in which any negative charges reside on the more electronegative atoms is generally the more dominant one. You're going to see that when we work an example in a second, but right now just kind of write that down. So we're going to do some formal charge practice. So if I've got Cn minus, I'm going to do the same thing I've been doing. We're going to say, okay, well there's 4 valence plus 5 valence from the nitrogen plus the 1 from the charge. I'm looking at 10 electrons. So my structure, I've got carbon attached to nitrogen, and then I've got, let's see, there would be, if you draw this out, I think there's going to have to be a triple bond between them, but that only leaves 6 electrons around carbon, so it is going to have a pair left over. So that's 2, 4, 6, 7, 8, so there's 9, and there's 10 for your structure. Now we need to look at formal charges. So carbon has 1, 2, 3, 4, 5 around it, and it's got 4 valence, so that's looking at a negative 1 formal charge. The nitrogen has 1, 2, 3, 4, 5. That's sitting at a formal charge of 0. So the overall structure is 1 minus, so that should be the correct way to draw that. So it does balance to the 1 minus charge. Alright, CO2. So if we look at CO2, we're going to have 4 valence plus the 2 times 6 from the oxygen. So we're looking at 16 electrons total. So let's draw a structure. You're going to start by saying, okay, there's a carbon attached to 2 oxygens. That's 2, 4, 6, 8, 10, 12, 14, 16. So you've got a structure drawn, but what you need to look at is, are the formal charges as close to 0? Actually, you're not even done with that one yet. Let me go back here, because you don't have an octet around carbon. So you're going to have to move that and get rid of that pair. And then that makes 6 around carbon, and then you're going to have to do that again. You're going to have to erase this pair over here and make a double bond there. So you've got CO2 there. But you could also draw this another way to get that octet around carbon. So let's just take a look at that one first. You could really do a triple bond, and you could have taken away both pairs from the right side. This one could stay like this. So that's just another way to draw it. So this is the point where you need to look at which one is the dominant one, and you find that out by looking at the formal charges. So let's start with the one on the right. If I look at the oxygen on the right, I've got 1, 2, 3, 4, 5 bonding electrons. Well, it's got 6 valence, so that means I'm looking at a positive 1 formal charge on that. Carbon in the middle, there's 1, 2, 3, 4 bonds around it. It's got 4 valence, so it's looking at a formal charge of 0. The oxygen on the right has 1, 2, 3, 4, 5, 6, 7 bonding electrons around it. It only has 6 valence, so there's a negative 1 formal charge. So let's look at the structure on the left and see if the formal charges are lower on this one. So if I start on the right, I've got 1, 2, 3, 4, 5, 6 bonding electrons around oxygen. It has 6 valence, so that's a formal charge of 0. Carbon in the middle, there's 4 bonds around it. It has 4 valence electrons, so formal charge of 0. And the oxygen on the left is exactly the same as the one on the right, so that would mean its formal charge is 0. Now, to determine which one of those is the most dominant, it would be the one that has the lowest formal charges. So this one over here, they're all 0, so that is your dominant one. That would be the one that you would give me as your answer. And we're going to do one line NCO minus. And I actually think I might save this one for the next video because this one can be a little bit difficult. So we're going to go ahead and end this now, and then we will start with this one on our next video. Thanks.